Hello and a very warm welcome to you. My name is Lucy Rycroft Smith and today I'm going to talk to you about board games, which is one of my favourite topics, and specifically board games and the number line. So I'll just move that away. Today I'm going to be talking about some research around board games and the number line, and then some practical ideas and applications through looking at my board game collection. As I said, my name is Lucy Rycroft Smith. You can find me on Twitter at honeypiesquared. So hello, and this is a picture of me playing a board game, and I included this picture because I thought it was important to challenge the definition of a board game. And the short answer to what is a board game is no one knows. There are a few terms that people use to define the kind of games that you might play with friends with some bits and pieces that may or may not come in a box. So board games, tabletop games, card games. Some people use analog games to differentiate them from video games. I'm using board games today to refer to quite a wide range of activities, products. In many senses, I'm not too worried about the definition, but it is worth noting that you might prefer tabletop games, and that's fine, or analog games, also fine. So hello, I am a doctoral student, so studying for my PhD at the University of Cambridge, and my area of research specialism, as we'll see shortly, is actually research itself. So I'm looking at how research is communicated to maths teachers. And so I'm hoping today to put some of that into practice by thinking about the research around board games in maths, and then actually thinking about some of those implications for maths teachers, for the classroom as well. So hello. So here's what I'm going to talk about. 5 different things. What on earth research informed might mean, because I am hoping that today, in some sense, this talk is research informed. What the research generally says about board games and maths, because that's a question I get asked a lot and I think it's quite interesting, so we'll do an overview of that, and I guess what's called the critical view of that, so some of the problems that I see. I'll give you 2 of the main ones. Then we'll look specifically at number lines, and there's not much research on this, as you might imagine, but there is some. And then the kinds of ways that numbers get represented in modern board games. We'll have a look at some of my board game collection, so I'm hoping that will be quite enjoyable. So let's start off then with this research informed idea, and this is really problematic, as I'm sure you can imagine. The short answer to this is we're not sure, and this is because, and I'm afraid I'm going to cite myself here right now, but I have just written a paper on this, and in this, one of the issues is this, that the idea of educational practice that is informed by research or research informed is not necessarily understood the same way by lots of different people, and so there is an issue here with maybe talking at cross purposes. So rather than come up with lots of different definitions and spend lots of time on that, what I thought is I'd just set out the stall for what I understand by that term for you. So I'm giving you a research informed talk today, and my conception of what that is, my understanding of that, is informed by this idea here of a cup of coffee. If you're familiar with espressos, which are the documents that I and my team help to write for teachers, they are supposed to be thinking about what kinds of research are there around different areas of maths education, but then also what are the classroom implications, you know, what does that actually suggest in practice for teachers. And one important part of espressos is they were always supposed to be the beginning of a conversation, and so the coffee metaphor goes quite a long way here, because having a coffee with someone is about thinking about a dialogue or conversation, and the research is the beginning. It's some kind of input, it's information, but it's not the only input of value. It's not the last word. It's not telling you what to do, what to think, how to react. There's a sense in which I would like research to be the beginning of the conversation, not the end here. So that's my conception of research informed. Research is one kind of input that might happen into a conversation or a decision-making process. It's not the only kind, and it's not the kind that I consider to have the most value necessarily either. Okay. So let's talk about board games and maths, two of my favourite things. And there's some interesting ideas around board games and maths. It's worth saying that there's been some reviews that suggested board games can improve student achievement in maths. And there isn't much research on this, but there is some, and that's one of the suggestions. And one of the ways that that might be thought to happen is because of the positive environments or attitudes that the games build towards mathematics, which is important. And there's also some idea that the amount of board game experience that children have at home might then correlate with their number knowledge. And what Romani and Siegler mean by number knowledge here, we'll get into a bit later, but ideas about magnitude, counting, what numbers are and how they work. There are some interesting studies that look at students that have lots of board games at home and play them at home. And there's some sense in which that aligns with their socioeconomic status, and that therefore their number knowledge might be higher on starting school or being in lower years of school. So we're talking about students who are perhaps 3, 4, 5 or 6 here. So again, quite young. So you see there I put more research is needed, especially beyond early years, because this is a really fascinating topic, and I think quite often the research has been concentrated on students who are quite young, and board games that perhaps for me don't even pass the test of being particularly interesting or fun to play. More on that later. So there's a bit of a roundup of the research on board games, and as I was looking at this for this talk, I did also come across a mention of this in the Ofsted Research Review, which you may have read. So this is what Ofsted have to say, which they use the word games, and it's not particularly clear whether this is board games or not, except that the paper that they reference is to do with board games. So I put it here in full so we can look at it, and I'm not paraphrasing it or interpreting it in any way for you. We've got this idea that substituting games into lessons may be an inversion of a particular causal pathway, and that might be something to do with the kind of way that students might learn. And so that's the quote from the Ofsted Research Review, and they've referenced this particular paper. So I went and read that paper because I thought that's an interesting way to conceptualise that. And as I said earlier, the idea of being evidence informed is problematic and quite complicated. And as somebody who reads lots of research and interprets it and writes reviews, this was interesting to me because this wasn't my conception of what the literature says on this particularly either. So I thought you might like to see what that paper actually says. Here's one thing from that paper. Now, this isn't what this researcher actually found in what they did, but they did review all the literature, which is what you tend to do before you start your own study. You say, what's everybody else found? And, building on the rest of the knowledge that's come up to this point. And this is the first thing they said. And again, not including that in the Ofsted Research Review is interesting because there's a suggestion here that perhaps this researcher found something which was different to what's been found before. They also found this. So there's a minor but statistically significant positive effect in this study. So that's interesting to me because reading the Ofsted Review doesn't suggest this at all. I had to go and dig in the paper for this. And so I had to read this a few times. Oh, there was something good about playing games in terms of students understanding maths concepts, because that's not really what's reported, and that's an interesting difference there. So I wondered, was there something else in this paper that Ofsted had found? And it turns out, yes, they also said some other things. So firstly, there was a suggestion that there was some quite anomalous data. And this comes back to, again, being research informed means maybe thinking about when you're looking at what research says, thinking about the studies themselves, whether they would be replicable. So would this study probably work somewhere else with different students? And so that considers context, how many students are involved, things like this. Is there lots of data that seems difficult to explain? And so maybe not necessarily hanging lots of conclusions from that data. And then this was interesting in this paper. So we've got comparing effective game playing with other things that aren't games. And there's the conclusion, not supporting that games are a very useful vehicle. So again, I'll let you read that. So teasing this out, there's lots in this paper that's quite confusing. You know, if you had to summarise, does this paper support games for mathematical learning or not? The answer is it's complicated. But here we have very specifically playing games versus doing other things, and all we have here is varied non-game activities, so it's difficult to tell exactly what that is. Playing games instead of that suggests that the games aren't better. Well, okay, but that's quite an interesting way to phrase it, and quite an interesting way to ask that question, I suppose. So that's something that I found interesting in that paper. And then finally, the conclusion that this researcher drew: primary mathematics classrooms should not have a heavy emphasis on games. So again, thinking about what was originally said in the Ofsted Research Review, I think there's a lot more detail in the original paper that is much more interesting to consider for me. So that was a little diversion. Here's some of the issues with the field at the moment as it stands on research on board games and mathematics for me. So this is my interpretation. The first one, and I've just tried to give you an example, is a real lack of detail, specificity and clarity in the research questions and the conclusions, which affects the ways that we might be able to use them in the classroom. And so what I mean by that exactly is, if you look at some of the things I was talking about in the previous paper, it's really difficult to pin down exactly what this might mean for me as a maths teacher. You know, playing some games might be a less useful activity than doing other types of learning for a particular mathematical goal. Okay, yeah, but also within the whole field, maths learning can be supported by playing games in some contexts. Yep. What I need is to know what are the mechanisms that are really successful, maybe much more detail, you know, what kind of learning, what kind of thing are we talking about, what kind of games, and really get into specifics about the way that we play those games with children and what they are doing when they're playing those games, the kind of talking they're doing about maths when they're playing the game, the kind of representations of number that get shown to them in those board games. And that's what I'm going to talk about today, because I think that's really important. So that's what I mean when I say detail, specificity and clarity. And then the other problem with research on board games, I came across this lovely quote, which I'm going to share with you. Educational activities disguised as play, this conception of them as chocolate covered broccoli. Oh, I should say broccoli. So this is really interesting to me, because I'm sure that colleagues who work with young children in the early years recognise this concept, that we should take learning, and particularly maths, because maths is hard and rigorous, right? We should take learning, which is the broccoli, and we should disguise it. So put the chocolate on, maybe some sprinkles, and that's the play, and therefore get the children to eat the broccoli by disguising it. You know, there's something deceitful about that, isn't there? And there's quite a lot in the literature which kind of assumes this position, you know, assuming that we're trying to get children to swallow that spoonful of mathematical medicine by popping some sugar on, and that sugar is the games or the play. And I think the major problem for me with that conception is it makes me feel like the assumption is there's this kind of continuum here that they're presenting, or a dichotomy with maths on the one hand and fun on the other. And there's the problem, because if we start there, if we start with that idea that we've got maths on the one hand and fun on the other, and they're distinct and they can't cross over, you know, what implicit messages are we getting there? And I think we're all familiar with the kind of thinking that produces in students, you know, when they really have this idea that maths can't be enjoyable or engaging from quite young. And that's a barrier that many of us face when we're trying to teach maths. And I'm not saying maths has to always be fun either, but I think acknowledging that there may be activities that we can do that are mathematical and also fun, and sometimes those are desirable in the maths classroom. I think that would be a good place to start, and not assuming the position that maths has to be different from fun, distinct from play, and therefore that we can have not just maths and play, or maths or play, but maths with play or through play, and they can be happening at the same time together. So the next thing I thought we'd do is have a little play, just because I've been talking about playful maths and I wanted to show you what I mean by that. So this is a question I've taken from a game called Wits and Wages Family. And this is the kind of activity that I'm describing here that I consider to be fun, and I very much accept the position that not everybody would. So this is a part of the game. It's not the whole game, but there's a part of the game where you're answering questions that are explicitly numerical. And so there's 2 questions here, and if you want to, you can have a little think about what you might estimate the answers to be. And the idea of the game is estimation. So we're not trying to know the answers here. So this isn't about knowledge, it's about estimation. In days, what is the average lifespan of a flea? And then how many words are there in the King James Version of the Bible? And there's some background knowledge that it's useful to know here to be able to answer these questions. But overall, this is about numerical estimation. And so have a little think, maybe jot down a guess for both of these. And again, thinking about the difference between these 2 in terms of magnitude, and therefore how much leeway you're going to give yourself when I give you some answers in a sec, because you can mark this yourself. I trust you. So let's have the answer to the first one. So in the game, this is what's given. Apologies if you have any questions about this or think that the accuracy is incorrect. Please take it up with the game manufacturers, not me. So 90, which is interesting in itself, because quite often I don't measure things that long in days. So that's already interesting to me as a mathematician. And then let's think about the second one. So again, thinking about whether you were close, whether you were in the same kind of magnitude, and how you might think about that, measure that. And so I'm going to move on and give you another set of questions this time, but I'm going to change the constraints. And this is actually one of the rules of this particular game. How might your thinking change if now you're not allowed to go over the correct amount? So you have to be as close as you can, you're estimating, but without going over. So again, 2 questions. These are more popular culture related. So again, there's some things that you might need to know, or at least have a good sense of, to try and estimate these. So we've got Miley Cyrus, Cyrus's age when her TV show Hannah Montana debuted. And then how many movies Will Ferrell appeared in during the decade from 2000 to 2010. So again, jot something down if you want to have a go, play along. And again, thinking about this not going over the correct amount, because then you're not going to give yourself a point, marks, however you like to score this. So here's some solutions on their way. So 13 is the correct answer of this one, which is younger than I initially thought. And then the second one, here we go. So what I think is interesting about this game is I've used this game to teach many times, and I would definitely count this kind of activity as both mathematical and fun, but a lot of that depends on the context, the way that the teacher expertly draws out the kind of learning that's happening. Just doing the game, just playing it, isn't necessarily mathematical or leads to any kind of learning. And I think, you know, it's very easy to set that up as a straw person when you're conducting research, and I would make that critique of some of the research about maths and board games. Okay, so let's think about number lines specifically, which is what I'm going to talk about today. So we're just going to look at a couple of papers in detail, because there's been some absolutely fascinating research on this. Here's a paper by Romani and Siegler, and in this research, and again conducted with very young children, I think they were 4 and 5, these researchers took the idea of a number line in a game, and so you can see there the number line is being used to score or move along in a game. And they played a game with these young children, and there were 2 conditions that they used here. So there's a number line which has numbers on it, and there's a number line without. There's colours so that you can distinguish where you are. And they played this game with 2 groups of children, and then they looked for effects in terms of their number knowledge. And they were very, very careful with the first group who had numbers to encourage the children not just to move a certain amount by saying the number of the amount they were going. So for example, if a child was on space 5 and they were moving 2, not to take their counter and say 1, 2 to get to 7, but actually to start on the 5 and say 6, 7, and that's important. And again, this is what I mean by specificity and detail. That level of detail is really important to the study. And so then they looked at, as I said, a sort of pre-test and a post-test after the children had played this game for quite some time, to see if there was any particular difference in the students who had the number line with the numbers on versus the one with the colours on. And there were some really interesting differences. So there were some differences in what they called numerical identification, so being able to recognise numbers. And so you can see there's 3 different data points there. So we've got before, playing the game, immediately after, and then a bit more after. And so the red dice with the line, that's the students who played the version with the numbers. And then you've got the yellow one, which is the version without the numbers. And so you can see there's this noticeable effect of students who played the game with the numbers on the number line. They're getting better. They're getting better at identifying numbers. There was another type of measurement that the researchers took, which is a magnitude comparison. So again, comparing sizes of different numbers. And you can see there that there's something really interesting happening, that students again seem to be really getting better at that when they're playing the game. But actually the ones who had this number line with numbers on, the effect did tail off a little bit after that. So something interesting. And then counting, really big effect. And again, that's relating to the kind of conditions that the researchers decided to use with the gameplay. So I enjoyed that paper. I thought that was very interesting. And then the same researchers, and then they did this study where they took a number line, the same number line, and they wrapped it and made it circular. And so I thought this was a really interesting way to consider it, because I'm really interested in the conceptions of the number line and the different ways that the number line is presented. And this idea of circular number lines I've been thinking about for some time, particularly in the context of teaching time, telling the time and reading the time. And so you can see there that my very good diagram, they've taken the same number line and they've just wrapped it. So they had a start and a finish kind of wedge, and then they had the numbers going around, and the start and the finish were different. And that was the only difference. So again, they played this game with students, young students, and they looked at the effects. What were the effects? So you can see here that the researchers have concluded that the linear number board was very different in terms of the learning that students got from the circular one. And so what they've looked at, again, being very specific and very detailed in this research, is the advantages and the effects were very specific to measures that reflected understanding of numerical magnitudes. And what we're talking about here is a conception of numbers that is spatial, arranged in space, which is to do with the idea of the number line. One really interesting effect here is they found that students who had a very low pre-test performance, so students who came in without a lot of these skills, caught up very quickly, partially or completely, to children whose performance was initially more advanced, when they had the straight number line, not the circular one. So the straight number line did something that the circular number line didn't. And I really, really like this part of the paper where the researchers talk about this idea of numerical magnitude and how we may visualise numerical magnitude. Because I recognise the idea that people often confuse big numbers. So 400 million and 400 billion, you feel sometimes that politicians don't see any difference in those, which is worrying. But you don't necessarily confuse a 4 and a 40. And what's interesting there is there's something about magnitudes and potentially something about a mental number line maybe that allows you to get underneath the structure of the relationship between 4 and 40 and how they are physically related to each other in some kind of spatial way that perhaps you don't have with 400 million and 400 billion, which then meant that the students who had the number line that was linear were able to do some arithmetic that the other students couldn't. So it wasn't just that they were better at doing things that you might expect that were related to a number line, they were also better at doing things that were much more abstracted. And the researchers suggest that this might be that the mental number line is this retrieval structure for students. And that's really fascinating and potentially very exciting. So I really enjoyed that research. So when I was thinking about these papers and what they might mean, I thought about, well, I have a lot of board games at home, and a lot of them have some really interesting ways to represent number on number lines. And, you know, I'm loosely defining a number line here as a way of arranging numbers in space. And so I thought we could have a look at some of them, thinking about some of those things from the research papers that we just pulled out, thinking about, well, if a number line is a way potentially to encode information about numbers spatially, and then that has some effect on the way that we perceive number, what could these different representations suggest about numbers, and what might they hide or what might they omit about numbers? So here we go. Let's have a little rummage through my board game library. So here's a board game called the Shipwreck Arcana, which is a lovely board game, and currently I think it's out of stock. It was originally a Kickstarter. It is, I'm going to give you some information here. You can see it is designed by Kevin Bishop, illustrated by Matthew Bishop, because I want to make sure, firstly, you can get hold of these if you can, if they're available, but secondly, that there's a bit more understanding here about the kind of board games I'm talking about, because I'm taking quite a lot of these really out of context. I'm just giving you a part of the board game or an image of a selection of, you know, the way that scores are tracked or something like that. I'm not really talking about the way the board game works. So I really want you to be able to go away and look these up in more detail if you want to, because they're great games and there's much more to them than just what I'm talking about today, which is the number line representations. So in this game, I thought this was particularly interesting given what we've just heard about the circular or wrapped number line, because I'll show you this number line. It doesn't look circular, but it is wrapped, and by wrapped I mean in a circle, wrapped around from beginning to end. So game, there are cards, and this is one of them, and it's a way of tracking things in the game. And so if we have a look at this card, and you don't need to worry about the middle of what's going on in this card, around the outside of the card you will see we have some numerals, and they're in Roman numerals, and the green counter and the red counter are tracking something, and they're actually tracking things comparatively. If they catch up to one another, we're in trouble. And what I found interesting about this conception of number as a number line was, firstly, it's wrapped, so it's circular in some sense. Secondly, it is in Roman numerals, which is interesting, and I think that's a style decision, and potentially also because it's supposed to be representing time in some sense. That can be quite confusing, because we're used to having time maybe as circular, but equally we're not used to having time that only goes up to 7. And I think it's interesting, the decision to have 0 and 7 as different here, because again that's maybe different to the way we've seen represented on a clock. I think it's interesting to think about the distances here relative to one another. So if you look at the difference there between 0 and 1, and you look at the distance between 7 and 0, or if you prefer 5 and 6 and 6 and 7, what does that tell you? What inferences might you draw there about numbers? And so I thought this one was quite interesting as a start, as a way of conceiving of number in space. And like I say, this is a game called the Shipwreck Arcana, and so much of this is about expediency. You know, this is a game that's played with cards and little counters, and so perhaps there wasn't room in this box for something that was a long number line, and so this is about being neat and using a card to track this in a particular way. And so many of these decisions are design decisions, aesthetic decisions, as well as mathematical decisions. Here's a game called Seven Wonders Duel. And this is a game which is a version of Seven Wonders, a larger game. And so duel refers to it being a 2-player game. And the duel part is very interesting because one part of the game involves this. And I appreciate that's quite hard to decode from the top down. What you have here is a number line. And in fact, it's a number line potentially with negatives if you interpret it in that direction. So you can see, I think, lots of oval shaped spaces. So ignore the circular spaces at the top because they aren't important to what we're talking about here. There's some oval spaces and there's a counter on one of them. So that counter moves throughout the game. to track a particular variable. And then there are some numbers along the bottom. So I'll show you, I've kind of decoded this for you here. I'll show you what that looks like. I've interestingly chosen to decode this as a positive and negative number line as one of the players in the game. It would switch the other way if you were the other player, and I'll explain why. So the 0 represents the middle position, neutral, which is where that counter starts. And then throughout the game, this is a tug-of-war mechanism. So at different times, I'm trying to push that counter into my enemy territory. And if I manage to get it all the way over to -9, I win the game. There are other ways to win the game, but this is one of them. And if they get it over the way to the area of mine, which represents +9, then they win the game. And equally, there's some other stuff happening where you can see a 2, a 5 and a 10 area on both sides. And that represents, at the end of the game, wherever that counter is marking, there's some points to be had. So I thought this was really interesting because the green part for me is probably what I see when I look at this in some way. There's an imposition probably of positives and negatives on this number line, but equally there is definitely a number line representation happening there, whether the numbers are put there or not. And so there's a lot about this that I find very interesting, would like to look into much more. Here's a game called The Castles of Burgundy. It's a much loved board game, and there's something really lovely about this one that I'm about to show you. I'm going to show you the whole board, so the scores get tracked around the outside of the board, so it's quite complex because all of what happens in the middle is the kind of gameplay stuff. So here you go. So we do all kinds of things with tokens and dice and things in the middle of the board, and we have our own player boards too, but notice, if you will, the number line around the outside. And see what you notice. That's right. So we have a wrapped number line or circular. I haven't spoken about clockwise or anti-clockwise, but I think I'm right in saying everything's been clockwise so far. The numbers are all facing outwards, oriented outwards, which is something I noticed too. We have a different colour every 5. And then, very interestingly, right at the end, we have this kind of concertina effect happening, and I'll zoom in to show you that. So the designers run out of space, intentional, who knows. They have kind of squished up like a little serpentine bit of the board, the number line to fit it in. I think it's interesting they've taken the decision to do that with the highest part of the number line here. Maybe that was the right decision. It does make for quite an interesting looking number line. And something else to note here is it's perfectly possible in this game to score above 100. And you'll see there you've got 0 and 100 on the same square, which looks a bit odd until you realise that it's possible to score above 100. Actually, it's possible to score above 200, maybe even 300 if you're very good. And so this game, like many other games, makes use of quite a weird mechanism mathematically, which is a counter that you just pop on to show that you've reached the 100 mark and now you're past it. And so decoding that information is actually really hard, even for me as a mathematician. When I look at my counter, I have to read where I am spatially on the number line, and then I also have to kind of think of it as another dimension. I'm sort of on another level as well, which has some implications about the way that I'm perceiving number there, which I think are really interesting. So that's The Castles of Burgundy. Here's a game called The Quacks of Quedlinburg, which is a lot of fun. It's a kind of push your luck game, so let's just take a moment to enjoy that art there. And you'll see it's got a logo there to suggest it's won a prize called the Chemiespiel des Jahres, which is an interesting prize to win, but it's a very good game. And here around the outside of the board again we have this wrapped number line, starts in the bottom left again, and we've got something weird going on where they're kind of sort of straight lines on the top and the bottom, and then an interesting zigzag effect happening left and right. I think they're trying to highlight every multiple of 5 in an interesting way to orient yourself, but that kind of goes a little bit awry when it's zigzag as well. It's quite difficult to see. And then there's also another tracker which is zigzag in the middle, so this makes for quite difficult decoding at first. But what's really interesting about this game, so this is to track people's scores. You also have individual player boards which look like this. So we have a spiral number line here, And this is a very complicated number line, because the more you look at this, the more you might notice more information on it. We have a spiral starting in the centre going outwards, which is interesting, suggesting perhaps an infinite number line. And so there's actually two sets of numbers on each part or each mark. There's other information happening there. What's interesting to me as a mathematician here is that the way that the different parts of the number line up or don't line up is difficult to predict. And so I was thinking about replicating this without looking at it, and how hard that would be as a task. So if you have a look at the detail here, there's quite a lot of information encoded there, and what this may or may not tell you about number in terms of the repetitions, the relationship between the number in the bubble and the number on the parchment is quite interesting too. And of course, this is all in service of interesting gameplay. It's very well designed, but in terms of what it tells us about number and a number line is a completely different question. Here's a game called Suburbia, which is played with hexagonal tiles, and you'll see in a minute that it has hexagonal tiles because there's spaces for them to go in. And as I was talking about before, a negative number line, this is another game which does happen to have negative numbers. So here we go. So this is my sort of player tracker, and you can see where the hexes go, and I create this really exciting sprawling city, hence Suburbia, and there's room there for me to track two things. So actually it's a double number line with negatives, and so I track my income and I track my reputation, which are things that can vary throughout the game. So it looks like this in the gameplay, which is where those things get tracked. And interestingly, there's a relationship between income and reputation, just as in real life. And then also in Suburbia, again, we have a way of tracking the actual scores during the game, which looks like this. So something we haven't seen before, completely serpentine. So starting bottom left, we are going to the right and then to the left and to the right and to the left. So this kind of conception of number as a number line, I find quite difficult to orient myself in. And what makes it potentially more complex is they have highlighted multiples of 5, but then some of these are bigger. So in order to make this serpentine structure, you've got the ends being bigger, so more space taken up by particular values, which is interesting. And then you may notice the red parts of this, which are barriers in some sense. This game is a really interesting game, kind of like a race, and there's a sense in which to stop some players getting too far ahead, this is a catch-up mechanism. So when you hit a barrier, certain things happen to mean you can't race ahead too fast. This is a game called Gloomhaven. You might note the cost of this game is quite large compared to others. It's a huge box, there's loads of stuff in it, and it's very, very exciting and lots of things happening. I'm only going to show you a tiny part of it, and that is this, which you might recognise from lots of different types of games of this sort, where you're tracking things like health and experience points. And so throughout the game, each person has one of these, and they keep a tracker on their health and experience points, which vary throughout the game. And what's interesting about this, of course, is we have number lines which are circular again, but they're hidden. And so what's going on here is behind here, if we just, there we go, you can see that there's a number line on a wheel, but we don't see it. So there's something interesting happening there, a kind of black box effect, that when I just see the front of this, what am I assuming about what's behind it? And equally, they are what's going on about the size of the number, the relative size of the number, when it's on a wheel that I manipulate up and down throughout the game. Okay, here's the last one, because I thought this was probably the most interesting, because in this game it is the goal of the game to construct a number line. That is the point, really, and it's a really interesting game. There's lots of versions of it. This is just one version. They come in sort of different flavours, and so here we have what the game might look like. There's lots of little cards, and they have different interesting things that might have happened throughout history, and you can see on those cards they have the date on. When you as a player get cards in front of you, you have the other side, they're turned over, so you don't have the date, and as you might have guessed, you're trying to think about whereabouts they go in the timeline that's in front of you. And so what's really interesting about this, again, is thinking about timelines in terms of chronology. Whereabouts does, you know, the thing that I have in front of me go in this timeline? There's some historical and kind of cultural stuff there, but also mathematical. And so what you could do here is think about, well, you know, could I place this on something that's already structurally existing so that I could think about consistency? Because at the moment, if you look at this, for example, the gap between the first two quite large. And so I'll show you what it might look like if you're playing this game. You have a card in front of you like this, and then you're trying to figure out whereabouts it could go. And it's worth saying it could go right at the front or right at the end as well. And so the way that you put these cards in space in front of you while you're playing this game is, you know, to some extent up to you. And I think that's very interesting in the way that, again, we conceive of number spatially. Okay. So really, what I'd like to say just to end is I'm fascinated by the idea that we could be doing all sorts of mathematical learning that might be supported by lots of different spatial models of number in board games. There are really a limited number that are available, and they have been, I think it's fair to say, quite often designed without thinking about mathematics. They've been often designed to think about what fits, what's expedient in terms of what fits in the box or what fits around, or how to put something on a card. And maybe sometimes a little bit of attention being paid to mathematical conceptions of number in space. And maybe as maths teachers we can go kind of from the other direction and use some of the components of board games to think about what sorts of conceptions that might give our students. Because even when they're problematic or difficult, you know, such as the quite funny one that I was showing you, you know, where they've concertinaed it at the last minute, I think we have a lot to share and enjoy there in the mathematics classroom, especially with older students, where they can handle looking at those because they can move between different representations and they've got more sophistication in order to think about different conceptions and different representations of number. So that was me talking about board games, research and the number line. And please don't forget, it's okay to have fun. There's me having fun playing a board game. And here's just some of the references I've used today. Here's my email address. If you'd like to talk to me about some of these things, I would absolutely love to have that discussion with you. And I have really, really enjoyed researching, writing and giving this talk. And I would love to talk more about this. So if you would like to contact me about it, please do. I would love to hear from you. Okay, thank you so much.